Here we don't have this pipeline solved. If we look here, because there is not enough information for the calculation, because our gas well number 3 is not fully defined. So how to define this one? We are going to do a back calculation. Instead of mixing these two streams together, I'm going to mix this one with this one, which means I have one defined and second one not defined, and I'm going to equalize them together. Okay, so how I'm going to do this? In this case, I'm going to add a pipe segment. This pipe segment will be added for G1 out. This is a material stream, so it needs to flow inside a pipe. So in this case, I'm going to add a pipe. This is our pipe segment, and I'm going to add it here. Double click to open it and to update the information. So in this case, it would be our branch number 4, and its inlet will be G1 out. This is the outlet from the mixer, and the out here will be our P4. This is our branch number 4 out. The same manner we are going to do P4Q, and we enter the parameters. Here we are going to check if we have 2 phases or 3 phases. This is 2 phase, this is 2 phase, so this one will be 2 phase. Okay, here I'm going to choose Tulsa Unified Model 2 phase for the 3 of them. Okay, and again 2 phase. Okay, so now I'm going to enter the rating to do the sizing. For the sizing, here we have only one segment, so I'm going to append only one segment with a length of 355. This is a very long pipeline or equivalent length, and with the change of elevation, we are going to add it under the ground with 400 meter depth. Okay, now I'm going to view the segment to choose the schedule, which is 40, and also I'm going to choose 100 millimeter nominal diameter. Okay, 100 millimeter. So we have defined the information. We have heat transfer information under specified, so I'm going to estimate because I don't have any information, so I'm going to add 5 here. Most of the time you will be given 40 degree Fahrenheit ambient temperature or 5 degrees Celsius, so I'm going to include both of them, and I don't have insulation, so I left it unchecked, and I'll include outer HTC. Okay, so now it's solved. So at this point, I'm going now, I have this one and this one. So now I am going to add a mixer. Okay, this will be my second mixer. So I'm going to add a mixer here, and this mixer will be added here as my second junction. I have the first junction here, so this is my second junction number 2. And for junction number 2, I have 2 inlets. The first one is the B3 out that I've created, and also B4 out. Okay, these are 2 material streams, and the outlet will be my junction 2 out. And now it's not solved because we have one of the stream is not defined. So to solve it, you are going to go to parameters and equalize all. Okay, so now we have equalized all the streams. Okay, make sure just you have checked equalize all, because sometimes you or it's the Aspen has itself a switch between both of them. Okay, so equalize all. Now this one is fully defined and solved, and surprisingly the branch is solved because now you have done a back calculation. Okay, so now this one, our branch, third branch is calculated, and now we want to know the pressure inside this one. Okay, here the pressure at the well, because we didn't have it at the beginning, so the pressure at the well is calculated to be 4,245. Okay, this is done by a back calculation. The same way we are going to do for our gas well number 4. We are going to add a pipe segment for it, which will be our 5th branch, and we are going to mix it with our G2. Okay, or we are going to add a pipeline here, pipe segment here, and we are going to mix the gas well with it. Anyways, we are going to do the same way for our gas well number 3. Okay, F4, because I want to my model palette, and in this case I'm going to add a pipe segment for G number 2. Okay, and I'm going to add it here. This one we reached now our branch number 5, and its inlet will be G2 out, and the outlet from it will be number P5 out, and we have the energy of P5Q. Now we have this one. This is stream with 3 phases, which means after mixing, this one will also have 3 phases. Okay, from parameters we are going to choose this time our 3 phase, and this one 3 phase. Okay, after that we are going to the rating. Here we are going fast because we have done this before. Okay, sizing, we have here only one segment, it's a pipe, and its length is 300, and it's under the ground with negative 16 meter depth. I'm going to view the segment to add schedule number 14, and it shows the nominal diameter of, in this case, 150 millimeter. Okay, this is equivalent to maybe 6 inch. Because we are dealing with 3 phase, our increments we are increase it to 10, and we are going to estimate our heat transfer. So this one will be 5, and again we have to include and one small include. Okay, we haven't include any insulation because we still don't have any information about it, and actually our branch number 5 is solved. Now we have to add our next gas well. This is our gas well number 4, and this time we are going to insert a branch for it, or a segment. So F4 again, and we are going to add a pipe segment for our 4th gas well. Okay, an error happened here, so I'm going to add it again, and I have an area problem. Okay, now it's added. Double click to open it. We reached branch number 6, and the inlet will be our well number 4, and the outlet will be P6 out, and we have the energy of P6Q. Here we have we don't know actually, so let's go to well number 4 and know the composition to check if there is a water. No water, so it's a 2 phase. So here we are going to choose from the parameters only 2 phase. Okay, and always Tulsa. Okay, and 2 phase, and then we go to the rating. In this case we have 2 segments, so from the sizing I'm going to add 2 segments, the first one and second one. The first one length is 180, and it's negative 7.6 under the ground, and we are going to view our segment to choose schedule number 14. From here we are going to choose 14, and our nominal diameter will be 80 millimeter. Okay, after that for our second segment we have a length of 165 meter, and it's negative 8 under the ground, and again we are going to view our segment to add 40, and for here we have also 80 millimeter. So now we have added all the information. It's time to add the heat transfer information. So here we are going to estimate our HTC, and the temperature is 5. We are going to include, we don't have insulation, so we are going to include outer HTC. There is no enough information. This is the same way as well number 3. So in this case we are going to add another mixer. Okay, so here we are going to add another mixer, and this time we are going to mix P5 with P6 out. So mixer, and this mixer will be our junction number 3. so it will be added here, and this one will be a little bit long. Okay, we have junction number 3, and its inlet will be B5 and B6. So make sure that you are choosing the energy, not the Q. And the outlet will be G, our junction 3 out. And it's still not solved because we haven't go to the parameters and equalize all. After that, it should solve. Okay, so sometimes you just keep going on to equalize and not equalize. So here and equalize all. Okay, so you will keep switching between them, and at some point it will be all equalized. So now we have calculated a back pressure calculation for the pressure at our well number 4, and which equals to 4,144. So now we have finished our information here, but still we need to add our final pipeline here. Those branches here all are mixed, and at the end they must flow through our final pipeline, or our last pipe segment or branch. So we are going to add it here, and it will be our branch. Okay, there are a lot of branches, so I think we reached branch number 6 or 7. Okay, so this is branch number 6, so this is 7, branch number 7, and the inlet in this case we have only one stream, which is G3 out, and this case will be 7 out, and the energy will be P7Q. Okay, so now we need to choose, because we mix it 2 phases with 3 phases, so our final stream will be 3 phases. Okay, and the last one is 3 phases. So it's time to the rating and the sizing. In this case we are going to have only one segment, so add only one segment. Its length will be 340, and it will be under the ground with a depth of 14 meters. And we are going to use the segment to choose schedule 14, and we choose a nominal diameter of 150 millimeter. Okay, so this information are done for the sizing. So now it's time to estimate our HTC, and in this case we are going to add the estimate ambient temperature to be 5, and we are going to include the pipe wall, the inner HTC and the outer HTC. Okay, so now it's solved. So this is the gathering. Okay, if you are working as upstream, you will be more familiar with this one. You have different widths, and all of them pump in a different branch. After that you collect them together like this, and this will be the pipeline or your final pipeline. Okay, so now we are done with our gathering information. So most of the time it's recommended to go to the performance and check each distance and what is the profile of it. And also when you are working with 3 phases, even if this one is 3 phases, we keep the increment to be 5. So it depends on the number or the information that you are given. Okay, if you go to the performance, and you can go and check the profile. Also we have here, this is the flow assurance, and in the next video we are going to talk about this, because this is really important. This is how you control the parameters. Okay,